Hey friends, so these notes are going to be 10.1, an introduction to logarithms. And what I have on the left are the notes we're going to take in class. And what I have on the right hand side of the screen is basically all the logarithm rules on one piece of paper. But all we're going to work on here in the beginning is converting a logarithm into an exponential. And your thought is, why would I ever want to do that? Well, you may or may not be very good with exponentials, but at least you have some experience with them. You've seen exponents before. They are something you have a little bit of a history with. You know that, 4 to the second power is 16, and 5 squared is 25, and 10 squared is 100. You know what exponents are. You may still be struggling with them a little bit, but at least you have a little background. You have really no background in logarithms whatsoever. So, since we don't have a lot of experience with logarithms, we're going to learn how to change a logarithm into an exponent, because logarithms and exponents are inverse functions of one another. So, what I have up here, let me slide this over a little bit because we don't need those rules just yet. What I have here in the beginning for you is, this is the rule. So this is the logarithm, and it is equal or the same as this exponent right here. So what we are going to do is we are going to change the logarithm to an exponential. And basically what you need to do is you need to basically put everything exactly where it is supposed to be in its template. If you think about, let's do this. Let's see, how do I want to... In other words, you'll notice right here is letter B, and right here is letter B, and B stands for base. It's all about the base, about the base, about the base. So in this problem, the base is a 3. So our base in our exponent is, whoa, hello, that is way too large. Let's go a little bit smaller. So the base in our exponent would be 3. Then we have this number right here, which is going to be our power number. So we are going to have 3 squared is equal to the number 9. And the number 9 is right here, and you'll notice that that is right there. And that's also a true statement, that 3 squared is equal to 9. So 3 squared is equal to 9, that's the exponent. A logarithm would say logarithms whose base is 3 of 9 is equal to 2. So those say that they are equal to one another. They mean they have the same value. So, alrighty. So let's look at this one. So again, I guess I could have. So let's go. You know what? Let's do this. Let me erase this, and I'm going to copy that so we can take it with us wherever we want to go. So now we have this problem, and we want to change it. Whoa, hi, that's really, really large. Okay, so we want to change it. So we are going to say that our base number is, hello, different color. Be consistent with your colors. Our base number is 6. So our base number is 6. Our exponential number is 3. And that is going to equal our value, which is 216. And that's also a true statement that 6 times 6 times 6 is 216. Okay. So let us try this one. smaller. Move it over here. We are going to say that this has a base of 7. So my exponential equation needs a base of 7. This has an exponent of 0. So my exponent in my exponential equation is 0. And any number raised to the 0 power equals 1. And so this is a 1. So this is a 1. So the logarithm base 7, 1 equals 0 is 7 to the 0 power equals 1. So all we're doing is translating. All we are doing is translating. We are not doing any solving. All we're doing is translating one language to another, if you will. Okay, so in other words, the base of this logarithm is 2. So the base of my exponent is also 2. Hello, I put E for exponent. My base of my exponential equation is a 2. The exponent, or the answer of my logarithm, is the exponent of the exponential equation. So that is a 4th power. And it is going to equal this number of the logarithm, which is 16. And it is true that 2 times 2 times 2 times 2 is 16. Okay? So now we're going to turn it around. So now we're going to turn it around. So what we're going to do now is we are going to take this and we are going to turn it into, wow, that's really, really large. Don't understand why it won't let me make it smaller. So not worth it. We're going to turn it into this. Sorry, struggling here with the technology. So now we're going to go the other way. We're going to start with an exponential equation, and we're going to write it as a logarithm equation. I don't know why it will not let me take this back the other way. It won't let me make it smaller, so fine. So all of this. So when I have an exponent that has a base, oh, we're not even ready for that yet. Dang it. All that effort for nothing. All you're doing is destroying your video at this point in time. Whatever. So we're going to do that again. This time we have a base of 4. So my base is going to be a 4. My exponent is a negative 2. And it is going to have a value of 1/16. And 4 to the negative 2nd power is 1/16. Because 4 times 4 is 16, but the negative 2nd power puts it in the denominator. All right, now we're going to go in reverse order. Now we're going to take the exponent and change it to the logarithm. So this time in our exponential equation we have a b. So that means we are going to write log whose base is 14 will have a, I think it's this color we want to use. Of 196 is going to equal a power of 2, is going to equal 2. So if we do that again, I'm going to follow the rule. And the rule is, if my base number is 3, then my base number will be 3. So I'm going to have a logarithm that has a base number of 3. I have an exponent let's not do the exponent, let's do this number. This is an 81. So I put that in the wrong place. The base number is 3. The 81 is going to go here. And the power is going to be the 4. Because there's the power, there's the power, there's the power. And then we're going to do that again. So, same exact process. Let's see if I can do this a little better this time. So, I have a base number of 36. So when I write a logarithm, I'm going to write a logarithm, and I'm going to say my base number is 36. I'm going to say that what I get is 6. And so right here, I'm going to put a 6. And that must have been a half, which is going to go right here. And there. Okay, let's try again one more time. So, I have a base number of 2. So the base of my logarithm needs to be a 2. So I have a logarithm that has a base 2. Here is, whoops. Here is x. Here is x. And here is x. And so 1/8 is going to go here. And then here's the exponential. There's the solution. So that is a -3. Okay. Alrighty. So now it's clear as mud. This is basic. So now the directions you'll notice change from convert to evaluate. So basically, this is what this is saying. This is saying what power of 7 will equal 49. Well, 7 squared equals 49. So the power must be 2. So the answer to this question is 2. So this is saying what power of 3 will get you 64. In other words, it's saying 3 to what power equals 64. That should be 4. Dang it. That is a typo. I need to fix that. This should be a 4. My bad. That's a 4. So then this should be, the question should be, what power of 4 will get you 64? In other words, 4 to what power will get you 64? Well, 4 to the 3rd power will equal 64. So the answer to the question of what is the power going to be, the answer to the question is 3. Okay. I'm doing a terrible job of this. Hopefully when I present it in class, I'll do better. You'll notice that in this problem, there is no number right there. When there is no number right there, this is called a common log. And common logs are really scientifically related. And so it's really related to scientific notation. And so when there's no number right there, the understood number, the assumed number is a 10. So this is saying what power of 10 will get you 100. In other words, 10 to what power will equal 100? Well, 10 squared is equal to 100. So the power would be a 2. So the evaluation of this problem would be a 2. And, by the way, over here in the notes, where do we talk about that? Right here. And this should be this shouldn't have, there should be nothing right here. So when there's the word log without a number on the base, the assumed number on the base is a 10. So that's that rule. Okay, the next question right here, this one, is going to say, let's do this the way you've been doing it. This one says, what power of 12 will get you 1. So in other words, 12 to what power is equal to 1? Well, we have a rule from Algebra 1, integrated Algebra 2, that says any number with a power of 0 will equal 1. We have a rule of that. In other words, if you took 4 to the 0 power, that's going to equal 1. 7 to the 0 power, that's going to equal 1. X to the 0 power, that's going to equal 1. So 12 to the 0 power is going to equal 1. So what power is it? It is the 0 power that's going to equal 1. So if it's the 0 power that's going to equal 1, then this evaluated is 0. Okay. So that is something that we learned in integrated Algebra 2, and we probably haven't talked about it in a long, long time. So I'm sure it's been forgotten. Okay. Then you're going to have things like this. And here's what you're going to notice here. You're going to notice that this is a base 4 and this is a base 4. If they're both base 4 numbers, the answer to the problem is 6. Okay? This is a base 5 number, this is a base 5 number, so the answer to this problem is 10. This is a base 2, this is a base 2, so the evaluation of this is 7. This is a base 3, this is a base 3, so the evaluation of this is 11. Over here in the notes, where does it tell us this? It tells us this in these two places. So this set of rules right here says that if you have a base and a base, then the answer is X. And if you have a base and a base, then the answer is X. So that is those two rules. Okay. Really, these are not nearly as hard as they are. I would just follow these rules. I would keep the set of notes or the set of notes with you at all times and just follow the steps right now. This is just an introduction. We do not have to be masters yet. Okay, my friends, that is a very poor video. I'm sorry. I probably, yeah.